Good morning, this is your Stats Sensei, Mr. Spensei, and we are going to do a warm-up on a confidence interval. We're not going to go through the whole thing, but we're going to do part of it. So in an early election campaign, a random sample of 800 registered voters showed 460 in favor of a particular candidate. Just before the election, a second poll consisted of a random sample of 1,000 registered voters, only 520 expressing the same preferences. There are more than 300,000 registered voters, create a 90% confidence interval for the difference in proportion of voters who support the candidate. All right, so we have early on, so we're going to have a call that the first poll. We'll call this one the second poll so we can keep them straight. All right, so we have a random sample for the first one of 800, and that was given. For the second one, we also had a random sample, and it was of 1,000, so it's slightly larger, and that was given. So we can check those off. All right. So in this case, we have 800. So we have independent samples. So we have two independent samples. We can call them two independent random samples, would probably be better. So that takes care of the second one. And since I said two, I've taken care of both of them. The third one, N equals 800. 800 times 10 equals 8,000. And that's less than our population size of 300,000. So that's good. We can go ahead and check that off. The next one we have 3. And we go in, that sample size was 1,000. And 1,000 times 10 equals 10,000, which is also less than 300,000. So we're still good there. Now we need to check the normality condition for both. Well, that's going to be our NP hat. And in this case, we don't have P hat, but I really don't need it because I know that 800, so NP hat equals 800, and that is greater than 10, so that's good. Oh, excuse me, we had 460. We had NP hat equals 460, and that's greater than 10, so that's good. And over here we have 800 minus 460, so that's N times 1 minus P hat. And that's 340, and that's greater than 10, so that's good. Over here, when we go to the next poll, we have NP hat equals 520, and that's greater than 10, so that's good. And N times 1 minus P hat equals 1,000 minus 520, 520, and that equals 480, and that's greater than 10. So the sample is large enough to use a normal approximation. Well, our formula is P hat 1 minus P hat 2 plus or minus Z star P hat 1 minus P hat 1 over N1 plus P hat 2 times 1 minus P hat 2 over N2. So X1 is 460. That was our samples. That was the number of people in favor of them out of 800. And that gives us our P hat 1, because that P hat 1 is 460 over 800. Four 460 divided by 800. is 0.575, so about 58%, 57.5%. And for the p hat 2, we had x 520 out of 1,000. So this will be 520 over 1,000, which is now about 52%. So 0.52. We needed to calculate our Z star. And our Z star, in this case, we wanted to create we needed to create a 90%. So our C level is 90%, so 0.90. This is an inverse norm. Our area is 1 minus 0.90 divided by 2. And we're going to go to the left. So let's do that. Second vars, inverse norm, parenthesis, 1 minus 0.90, close parenthesis, divided by 2. Mean is 0, standard deviation of 1, because it's a Z, and we'll always use that. Now, we're positive people, so we're going to make this a positive Z score, so 1.6448. Now, the one thing it didn't ask us to do, but I'm going to go ahead and do, is I'm going to go ahead and run this thing and actually get the interval size. I'm going to find out what that interval is. So stat test letter B, which is 2 proportion Z interval. We had 460 out of 800. And then we had 520 out of 1,000. We wanted a 90% confidence interval. And I end up getting, whoa, something happened there. That's not right. Stat test. Two proportion Z test. Got everything in there right. And it looks like our difference is somewhere between 1% and 0.9% or 9%. So 0.0165, I'm going to go ahead and write that down because we'll probably refer to this later. So my interval, had it asked for it, would have been 0.01625, 0.0162 to 0.0937. Now we notice that both of these are positive. So that tells me the first number was larger. So the earlier pole was larger. It doesn't contain 0. So it is statistically significant. All right. I hope that helped. Sure hope to see you on the next one. Thanks for watching.